Okay, so let us discuss the doubts. If you have any doubts, you can of course send it to me. So let us discuss the questions here. Question number 5, it is: six identical particles each of mass m are arranged in the corner of a regular hexagon of side length L. Masses of any two sides are particles are double. They shift from the center of masses. So 1, 2, 3, 4, 5, 6. Right? Regular hexagon. You can draw this hexagon. Each masses are how much? Double. Means each masses is mm. Identical particle m, 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 m. How many? 6 particle. So by symmetry, where will be the center of mass of this regular figure? Tell me, where will be the center of mass of this regular figure? At the center. At the center. The center of this means if you join each of these, it's going to be equilateral triangle. You know about this hexagon, right? Each of these are actually equilateral triangles. So by symmetry, all the particles are same. So its center of mass, which is right now 6m. 6m, right? Center of mass means total mass 6m is at the center. Now they are saying that the masses of any two adjacent particles are double. Double means we are adding extra mass. Now suppose you are putting one extra mass here and one extra mass here. These are the extra mass you are keeping. So the shift in the center of mass. So previously this was the center of mass which you can take as origin. Now they are asking where will be the new center of mass. So now you need to consider that this is your origin already. Correct? Now this is your already origin. Let us take this is origin. Okay. And let us consider that this is your x-axis. This is your x-axis. And let us take that this is your you can take any direction as y-axis. Let us take this as y-axis. Downward I am taking. Okay, it doesn't matter. This is x-axis. This is y-axis. Okay. So now tell me, what is the system? The system is now made up of already this six mass, 6m because of all hexagon, and these are extra two masses. Extra two masses has come on adjacent sides. So now where is the center of mass? Now you calculate center of mass. Let us take this as origin. I have chosen this as origin means I am writing this as 0, 0. You know origin is 0, 0. This side is how much? Side length I think they have given L. So because it's a hex length L, so this coordinate will be L, 0. Note that I am taking x-axis like this way and y-axis downward. So downward I am choosing anyway. I am choosing this project. What? So this is a equilateral triangle, no? So all these are equal. You know or not this? I think you should know that each of these are equal. So then here this coordinate and because this point where it will be that you figure out where it will be, because each of this angle will be 60 degrees, 60 degrees, 60 degrees. We know that. So suppose this length is L. So this coordinate I can take projection. So this will be L cos 60 degrees. That means this is L by 2 and this will be L 60 degree root 3 L by 2. So now you know this coordinate also. So x coordinate L by 2 and y coordinate root 3 L by 2. I am taking this direction as positive, so do not worry, nothing is going to happen in calculations because we have to find the distance of the new center of mass from the original center of mass. So anyway, we are going to calculate distance, so no problem will happen. Okay. Now tell me, you know the x coordinate, y coordinate of all the points now. Now calculate the new center of mass, x center of mass. Let us calculate. So x center of mass m1 x1. So this mass is 6m. X coordinate is 0 plus m2. Let us take this is second. So mass m. Its coordinate x is L. M3 third mass is m. Its coordinate is L by 2. By total mass. Total mass is 6 plus 1 plus 1 8. 8m. So m terms will anyway get cancelled. Anyway, this first term is 0. 12 plus L by 2 3L by 2. 3L by 2. into 8. So that means we got 3L by 16. Similarly, calculate y center of mass. Y center of mass is m1, y1, y is also 0, plus m2 second mass m into y coordinate is 0, plus third mass m y coordinate is root 3 L by 2, divided by total mass, which is 8m. Again, mass terms will get cancelled. Two things have come 0, so that has become root 3 L by 16, right? So you got the new center of mass. New center of mass is 3L by 16 by root 3L by 16. Somewhere here new center of mass may be there. We do not know. Somewhere here maybe it will be there. Okay, this is new center of mass. Okay, so this new center of mass coordinate now you have got. What is the coordinate you have got? 3L by 16 by root 3L by 16. So now you know already previous coordinate, previous center of mass here, and new center of mass now you know. Can you calculate the distance formula? You know distance formula, na? I think you know distance formula, right? Distance formula you know. To calculate distance formula, calculate distance formula. You want distance between these two, that is the shift. Calculate. So that shift will be distance between these two center of mass. So root under, anyway this is 0 0 no, so this is square plus this is square. So 3L by 16 whole square plus root 3L by 16 whole square. Calculate. 16L by 16 will come out. This will be 3 square 9 plus root 3 square will become 3. So L by 16, 9 plus 3, 12. 12 can be written as 2 root 3. So 2 can be cancelled here. So root 3L by 8. That will be the answer. Clear? Next question number next. Question number 6. Three particles each of mass m are arranged at the corners of equilateral triangle. If one of mass is there. I think exactly same approach now. I hope now you will be able to do that. Because three masses are equilateral triangle m m m. Masses are m m m. So where is the center of mass? Center of mass is the geometric center. You know that. Where is the center of mass? Center of mass is the centroid. Centroid is the geometric center. Center of centroid. So total mass will be 3m because this is the center of mass. Now they are saying that one of them you are doubling, right? You are saying they are saying if masses of particle at the end of a side is double, one of the mass is double. Double means you are adding extra mass. That's all. Double does not mean anything. It means you are adding extra mass here. Where is this shift in center? Now you need to consider this 3m and this m. This 3m and m system now is 3m and m. Where will be this? This is a direct calculation now using formula because now this become a two particle system. This is 3m and this is extra mass m. Now this distance is nothing but I think this you can calculate. First you calculate this and tell me how much it will be. Side is how much? Side of this is L, smaller. Now tell me, if you drop a perpendicular here, this is 90 degree, and by symmetry this becomes 30 degree. You know that. So this is L by 2, definitely half half, right? L by 2, L by 2, and then this hypotenuse you can calculate. Maybe you can use cos. So this will be L by 2 divided by cos 30 degree. Cos 30 degree root 3 by 2, so this will be L by root 3. So you got this length, this length you know, L by root 3. Now tell me, for two particle system, you know now where is the center of mass. Directly you can calculate for a two particle system. Directly calculate for a two particle system. Let us say calculate from here because this was the original. From here they are asking shift. So new center of mass will be somewhere here. Calculate directly this mass m divided by total mass 4m into the distance L by root 3. So that becomes L by 4 root 3. That is the shift. This is the shift in the center of mass. Clear? Yes. But what is the answer given? L by 6, L by 6 root 2, L by root 2, L by 5 root 2. 4 particles. No, no, that was previous question. Sorry. L by 4. Okay, correct. Second option is correct. Similarly, like that, I think you can solve all other questions where masses are double, triple, whatever it is. Clear? This idea is clear to you. Yes? Okay, done. Any other person having, anybody is having any question on this type or any other type, you may ask, because I want to discuss, I want to continue the other questions which that the student has sent me that full questions, and he told me that he could not solve even means questions are so good level of questions, because in Alan generally this is such a means they are producing all India ranks, right? Their level of questions are very nice, okay, and it will be very nice to discuss that previous chapter work power energy. If you have any questions, you can ask. No? So I will just want to tell you one very important thing. Last class it was very interesting question, and still one question is still resonating in my mind where I have edited it again. That was a simple question which I have edited it again, and to solve that I needed some means special kind of mathematical tools. I needed that. So I will explain that question and then I will go to the questions. Very nice question it was. So this is a, you have seen that, right? This was like this circular track one. Now I am going to consider, I am considering that this is fixed still. I am keeping the simple case. The simple case I am keeping that it is fixed. This is not moving, it is fixed. Okay. And I am releasing a ball or object. I'm releasing this ball or object when it comes to some angle theta with the vertical, but this time I am keeping friction. I am going to keep the friction. The surface is a rough surface. And this change, this change in this question again makes this question an advanced level of question. That is the wonder of asking question. That is the beauty of asking question. So this initially was horizontal, it was released, so speed was 0. And when it comes to this position, it is making angle theta with the vertical. Now, they may ask a question that what is the speed right now at this angle? They may ask question, or they may ask what is the normal? What is the normal acting at an angle theta, and the coefficient of friction is mu they have given. For the surface coefficient of friction mu is given. This question I had given in grade 12 also, nobody could solve it. The reason is that they don't think, they may make equation, but how to apply the maths, they are supposed to know, grade 12 student, definitely. They are supposed to know the maths. Okay, it's not very difficult math, they know the maths, but they could not apply it properly. Otherwise, they could have solved it. Actually, 2 3 years back, again, same question I had in my mind. I was in Narana that time. I asked one senior faculty the same question. The same question I asked to that person also could not tell me how to solve that question. But recently, when I saw this question and I asked this question and I attempted it, I was also stuck with the maths, but I tried to solve that. I have just also taken help from maths expert, but it was then later I know it was not a very difficult thing. It was the little applications of differential equation, that's all. Okay, so let me tell you how to solve this question. Okay, very good question. Generally, people do not think about it. They should think about these things. Okay, so you are releasing it and it is coming here P. So what will be the normal? That is one question, or what can be speed? That is one question. So definitely, because friction is also working now, there will be free body diagram when you draw. There will be different forces. You can show that. What are the forces acting? You know already. Mg is acting this way downward. This one is smaller. The ball has mass is smaller. Right. Right now there is no rule for this. This. wedge, no roll right now because it is fixed. So this mg is there and this normal is there, right? Two forces are there. Plus friction is also going to act. Friction is going to work opposite of this. That means in tangential direction, friction is working, right? So these are the three forces, and definitely friction will be doing some work, so there will be loss of energy. There is no question of applying energy conservation. Some people will try to do, but you know, ultimately they are applying the work energy theorem. So work energy theorem is the best theorem in this chapter. Means overall work energy theorem is the best theorem which you can apply to solve any type of question, even if energy is not conserved. Okay, when we say energy is not conserved means we are talking about the mechanical energy, right? Otherwise, in general, energy can neither be created nor destroyed. Energy just converts. So, if energy is not conserved, means mechanical energy is not conserved because some part is lost due to friction that is converting into heat energy, right? So, mechanical energy is not conserved. Now, let us try to solve this question. So, first of all, work energy theorem we are applying. So, net work done is change of kinetic energy. Change, and we know already the height that it is falling, so we have calculated already the height because this was radius. So this height which it is falling is r cos theta. We have, and it is going downward. So work done, net work done means what? Work done by all the forces. Work done by mg plus work done by normal plus work done by friction is equal to change of kinetic energy, and initial kinetic energy was 0. It is the final kinetic energy, half mv square minus initially 0, right? So work done by mg is very simple. Mg is a constant force and its downward displacement. So work done by mg is just mg into h. That is quite simple. Normal is always acting perpendicular, so normal is not going to do any work. We know that. Work done by friction we need to write. So let us write, because friction is always tangential and tangent direction is changing always, right? So it's a variable force. So include integration friction dot displacement dr vector is equal to half mv square. Okay, you will be, by this question you will be learning the fine things about the maths involved, very fine and minute things about the maths involved in the problem. Okay. So this is an EV constant, this is mg, h is r cos theta. So mg r cos theta, this game is over, but main thing is here, how will you take? So friction is acting always this way and displacement dr is happening this way, right? Displacement of the body is happening forward. So this friction is opposite, right? And friction is mu times normal, mu times normal, okay? Mu times normal. So it is opposite, so I will write minus integration of f dr, f dr half v square. And this friction is mu times normal, so mgr cos theta. Mu is a constant, I will take out, so normal will remain inside. Dr is equal to half mv square. At this position we are getting stuck because we do not know how to solve it further. Further we do not know how to solve because we need normal. We need to know how to integrate normal, but normal we don't have idea. So to study the normal we have to study forces, and we have to consider net force toward the center. That net force toward the center is centripetal force. So net force toward the center, if you see the normal, I am writing like this way, normal, and mg is acting downward, you know that. So this angle with the vertical, that angle is theta. So mg, you know, resolution, this is mg cos theta, and that is mg sin theta. So you know the net force toward the center is normal minus mg cos theta. Normal minus mg cos theta. This is the net force toward the center, which is the centripetal force mv square by radius. Now we know these two equations. From these two equations only we have to solve this. There is no other equations. These are the only two equations by which we have to solve it. But the thing is that if you try to put normal here, okay, in this, the complexities will be there because speed terms will again come here. Here also speed term is there, but speed term will be, speed is changing with, you know, angular positions. So it is going to be a complex calculation. But the maths is going to help you how to solve this big problem. That is the beauty of the maths. How it will help, we have to see that. Okay. So, what to do? And also note that very important, very important thing is that suppose at an instant, this is the center, let us say, the particle has come here. This is the angle theta. Note that as this particle is falling from top position to this position, theta is decreasing. This is a very important thing to note. Initially, theta was 90 degree. Now, theta is gradually decreasing. So, whenever any quantity is decreasing, we should write d theta as minus d theta. We should substitute. Wherever you are treating d theta, you should treat d theta as minus d theta. Okay. That is one thing we have to understand. And also note that whenever you are taking a small displacement dr, and let's take this small angle d theta. So you know by trigonometry means by coordinate, this definition of d theta, angle in radian, is equal to arc length by radius. I think all of you know that. So when you're writing, calculating this, here d theta, you must write this as minus d theta. This is one important thing. That is what I want to figure out. Whenever you are writing d theta is equal to dr by r, you have to write here minus. Okay, so that's why dr can be replaced with minus r d theta. Dr can be replaced with in this equation here. Okay, first equation, right? That's how you can try to do that. Okay. Now, how to further solve this? So this equation which you are seeing, the first equation, let us label this as first equation and this is second equation. The first equation is giving integration of n dr, and even if you substitute n here as mg cos theta plus mv square by r, you will not be able to take out of integration. That is going to give you a complex calculations. So that is where I got stuck. And what strike me that here is that this is integration and n is inside the integration. Here n is outside the integration. Why not differentiate this equation? Huh. Why not differentiate this equation? Because if you differentiate it, it may go away, right? It may go away. So first let me modify this equation. Instead of dr, we will substitute that. So mg r cos theta comes minus mu comes and remains, right? Dr I am going to write as minus plus will become r is constant, comes out, d theta will remain here. Okay, is equal to half m v square, right? Now I am going to differentiate this equation with respect to theta. Let us differentiate this equation with respect to theta. So differentiating it with respect to theta. If you differentiate this equation, let us differentiate. So mgr comes out. You need to differentiate cos theta with respect to theta. Then note here that this mu r is anyway outside. When you differentiate, which is already an integration, that will give you simply n. that is where this calculation becomes little bit easy. So integration and differentiation are opposite process. So this is integration already, and when you differentiate it, integration differentiation cancel, you will get the same function n. Right hand side you differentiate, half m comes out. V square you differentiate, V square differentiation with V, chain rule 2V, and velocity with theta is dv by d theta. This you can do. Okay, dv by d theta you can do. So let it keep it like this. Here 2 can be cancelled, of course. Now this and we can substitute from equation number 2. From equation number 2 we know that I can take that side, then n can be converted in terms of that. Correct? I can convert n in terms of that, and if I substitute in terms of that, what can we get? Why it will balance? If it is balanced, how can it will be circular motion? You forgot. Last class we have done that. Na? There must be a net force toward the center, which is called centripetal force. So normal has to be larger than mg cos theta. Then only it will give a centripetal force. Huh. Hmm. What you say? Capital R you want to put it here. No. Huh. Hmm. Huh. But normal you do not know. No? Normal is also changing with time or theta. Normal function you do not know. That's a problem. Hmm. Even if you substitute capital and here dr by dθ will come, but normal you do not know how to do. So which one? Huh. What do you want to substitute? You substitute now. But what will happen with that? The here is integration, here will be differentiation. What will you do with that? Here will be integration, here will be differentiation, and speed is also a function. We do not know how to change. Okay. See, I think in right hand side half mv square which I have written, I will write mv square by r. I think right hand side I will first eliminate this. I will go with this step, but before going into this step, right hand side I will just edit that. Half mv square which I have written, na? Let me just, I will go with differentiation step, but before I am going in differentiation step, I will little bit change this equation number 1. mv square I will substitute from the second equation into the first equation. Okay. So mv square will be what from this equation? R will multiply that. Correct now? So see R I will take common and divide it here. That will be better. So this is mg cos theta plus mu integration of normal d theta, and this r I have divided, so mv square by r has come here, and 2 is also there. So now mv square by r from second equation I will substitute here, so that has become half n minus mg cos theta. Correct. Right. That's what it has become. Let us try to little bit simplify this. So mg cos theta plus mu integration of normal d theta is equal to n by 2. 2 I will multiply this side. Okay, 2 I multiply this side. This become n minus mg cos theta. Now mg cos theta terms I can bring this side. To bring this side, so 3 mg cos theta will be there, plus 2 mu integration of normal d theta is equal to normal. Hmm? Now I am going to differentiate this. Let us differentiate this. Differentiating, differentiating with respect to theta. With respect to theta. So 3 mg comes out. Cos differentiation will become minus sine theta. You know that. Plus 2 mu comes out. This integration and d theta with respect to theta differentiation will again give n. Now this becomes dn by d theta. This is an important thing. Okay, dn by d theta. Now this has become a differential equation, and in order to solve this differential equation, you have to learn Bernoulli's maths of Bernoulli. What is given? That I will explain. That I am not going to give detail, but I'll give you the approach of 1D, and this is a one-dimensional equation. Okay, and how to solve, I will tell that. But first of all, let me give you the form of it. So dy by dx plus p times y is equal to q, where p and q can be function of x. Okay, then we can solve this equation. So to solve this equation, we need an integrating factor called if is called integrating factor. That integrating factor is given as um, e per power integration of p dx. Okay, this is called integrating factor, and once this form is matching, then only you can go with that integrating factor calculation. And once you calculate integrating factor, the solution is given by this method. Solution is given as y into integrating factor is equal to integration of q into integrating factor integration dx plus some constant of integration. This is the solution. Okay, this is the solution. So first let us bring this in this form. We want to bring in this form. Okay, so dn by d theta is already there. This 2 mu n I will bring this side, so minus 2 mu n will become, and this I will keep it as it is, so minus 3 mg sine theta. Very, very important thing it is. Now we have got that in standard form. We got. So then we will be able to solve using. So we have to calculate now integrating factor, because see dy by dx means here n is the y and theta is like x, and here p is what? Let me write p. Comparing with this, I will write p. So p is minus 2 mu, and what is q? Q is equal to minus 3 mg sine theta. Okay, that's what it is. P and Q we got. Now let me write integrating factor. So integrating factor is equal to e power integration of p. P is minus 2 mu and x means d theta here. So we will got e per power minus 2 mu integration of d theta with means this theta. We'll write it like this. Without any limit, it is calculated. Okay, so like this we calculate. Now let us write the solution. The solution is written as y means n here, n into integrating factor e per power minus 2 mu theta is equal to integration of q means minus 3 mg sine theta into the integrating factor is e per power minus 2 mu theta, right, then d theta plus constant we will add afterwards. Okay, we will add afterwards with constant. If you want, you can add it, but let us add constant after the calculation. So here we got minus 3 mg constant to take out. This integration is e per power minus 2 mu theta into sine theta. Now I have to give you now another approach how to solve this integration. This integration approach I will give you, then we can solve finally this equation. Okay. So for this you need to again remember another formula. What is integration of e per power ax sine bx dx? This integration, it's a standard form which we are studying in grade 12. Okay, let me just give it. I forgot because you know how such a important math. I can derive it, but I don't want to waste time in deriving that. Okay, it's possible to derive it. This. So that form is e per power ax a sin bx minus b cos bx e per power ax a sin bx minus b cos bx divided by a square plus b square. Okay, divided by a square plus b square. Correct. So this is the formula. Okay, this formula we are going to use here. So right hand side I am solving. So minus 3mg comes out. E per power here what is a? A is nothing but minus 2 mu and b is nothing but 1. Okay, so use that. So e per power this will come out into a. A means minus 2 mu minus 2 mu into sine theta minus b means 1 sine theta. Sine or cos it is, sorry, cos it is. Cos theta. Okay, this, right, divided by a square plus b square. Age minus 2 mu whole square is 4 mu square plus 1. Okay, and this is n into e power minus 2 mu theta. Now this you can divide it, so this will get definitely cancelled out. So you will get n is equal to minus 3 mg. If you write here a constant also, you may write a constant, so you have to divide by e power minus 2 mu theta. Doesn't matter, you may divide it if you want. Okay, divide it. So when you divide it, because constant should be written now itself, you cannot write now after, because integration is over. So once integration steps are over, you have to now put constant. So I have put the constant c, and I have divided by e power minus 2. So this has become this 4 mu square plus 1, and this minus minus will become plus because this minus I have taken common. So 2 mu sine theta plus cos theta plus constant e power 2 mu theta plus some means multiply some constant. Okay, so this is what we have got normal. This is what we have got normal, but here this constant c need to be eliminated in this final, which can be solved by taking some initial condition. So if you see initial condition, if you see initially this ball was like this way, it was reduced. Note that initially speed was 0. Initially speed was 0, so, and mg was what? Mg was exactly vertical initially, right? And there was no speed, so there was definitely no normal here. Normal was 0 because there is no centripetal force initially because it was released. So initially means when theta is 90 degree. Remember, initial means when theta is 90 degree. Theta is 90 degree. That time we are talking about. If you take theta 90 degree and substitute, what do you get? So normal is 0, right? C mg by 4 mu square plus 1, 2 mu sine 90 degree will be 1, right? Cos 90 degree will be 0 plus actually theta is 90 degrees, so e to power 2 mu into c, right? So let me check that. Constant was given at the last time. Constant was given at the last, because otherwise here if you get this constant c, shall we get it here itself? Let's try. Let me try with this. Okay. Then from here what to get c? So from here e power 2 mu times c. If I am going mathematically correct, then it will be like minus 3 mg into 2 mu divided by 4 mu square plus 1. Then c will be calculated, or this value we can substitute in the solution. So in the solution, if I substitute normal, so 3 mg by 4 mu square plus 1 and 2 mu sine theta plus cos theta, and c into e to power 2 mu. So c I have to substitute. So c will be what? C will be this divided by this. So that become already minus 3 mg into 2 mu by 4 mu square plus 1, right? This has become, let me check the solution what sir has given, because in maths I have taken the help of maths, sir, to get it. But the solution which I have solved, it is little bit different. In terms of that is also coming. Yeah, that's right. Okay. So it is coming. Okay, let us go with this. So see, I am going to substitute here. So c is this divided by this. So this I have already put divided by e power 2 mu. right? E power power 2 mu, and this e power power 2 mu theta is extra here. E power power 2 mu theta is extra here. Okay. Now let me calculate normal here. So what is normal? This is the normal. So I will take some common thing now here, and here let us take 3 mg common by 4 mu square plus 1 common from the entire thing. Okay. So this term has come common. So this has become 2 mu sine theta plus cos theta minus. So this thing I have taken common, right? And this is 2 mu here remaining. 2 mu is remaining. And e per power 2 mu, and this I bring upward. So 2 mu theta minus 2 mu. So 2 mu I will take common. So theta minus 1 will be this, right? This is what is normal, and it is a completely advanced, solution. This is not a easy solution. You can see that this is the normal equation. Can you see this? This is the solution. Now once you know the normal is changing with theta, you can substitute normal in that equation and calculate speed also if you want, right? You can calculate here. But I want to cross check this solution. I want to now, I am suspicious. If I am suspicious, how do I check this solution? So for a smooth surface, we have calculated this solution, if you remember, for a smooth surface. Okay. So for a smooth surface, if you remember, we have calculated for a smooth surface last class. A smooth surface I have calculated. For a smooth surface, the normal formula was 3 mg cos theta, means solution was this one. So this solution will come when mu will be 0. Let us try to substitute mu 0 in the solution and check whether we are getting this result or not. If we are not getting, we will edit something in that. So let us check that. So 3 mg, mu is 0. So this is 0 plus 1. Then this term will become 0 plus cos cos 90 degree. Sorry. Cos theta only. Theta we are not substituting. Mu we are substituting. Aha, we are getting this. 3 mg cos theta. Correct, na? The solution is exactly correct equation. Did you see that? That is the solution. Which is for a rough surface. So you see, just making a smooth surface a rough surface, the calculation has become so difficult. The solution has become so difficult. This is the mentality of advanced toppers. If you want to really top JEE Advanced, you want to get all India rank within 100, then you have to think it like that. That question was a simple question. Now we made a question complex little bit by just changing few words. Last time we have, you remember, I made that by keeping it free. That hand itself becomes so complex. But maths was not tough. But here maths has become tough, so definitely this is a JEE advanced question. You understanding this? Yes? Yes. Tell me. Exam hall, you have sufficient time. Out of suppose you have, let us say, 10 to 15 questions. Even if you solve 3-4 questions, now you may get IITs. Questions are like that level. Okay. Questions are. It's not that all questions are tough, but the level of toughness is there. Okay. So this question is coming under tough type. There are some questions which are moderate level also. So initially you do not have to think of time. You have to think whether I am able to solve right or not. Suppose out of 18 questions, even if you can solve 6 to 7 questions correct without any mistake, definitely you will crack the advance. You have to think like that, because what is the cutoff? Cutoff is not that much high. Last year, some of the students also qualified for JEE Advanced. I told them you should write, but few of them did not write, also thinking JEE Advanced is very difficult. But probably if they could have written it, they would have got some chances. In some IITs, they would have got. So those who have got this time IIT, 5 of the students who got into IIT, It's not that they are very genius. They worked hard and they had confidence in themselves and they had confidence in teachers. That yes, whatever my teacher has taught, I am confident. I will try my best. They tried their best. They got. They got. Now they are in IITs. It is not very difficult. First of all, forget about it. Everything you can do, but you have to be little confident. You have to learn the exact way. Time will be. See, time when you are talking about time, that by practice it will come. By practice it will come. If you are not practicing, how it will come? If you are solving tough questions, you are thinking fast, doing calculation, you are good in math, this question can be solved within maximum 6 to 7 minutes, maximum, right? But I am here writing these steps slowly, slowly. I'm not a good in expert in math. I'm good in physics and thinking. I'm writing every step slowly, slowly. And math formula, I do not know everything. So whatever I don't know, I have to write it. But as a math student, you will be knowing all those things, right? Clear? So I hope you have understood this. One question which I have solved. Now I will take up some questions from his learn paper what he have given, and I will be solving those questions. Now you may ask questions also from this. Let us try to solve fast. Now you are talking about how to solve fast. Let us solve fast questions. Question number one. So this type of questions you have definitely solved in you. So suppose this is radius r, and they are saying that there is a body which is moving like this way, right? A small block slides with a velocity. So this velocity v naught is given as 0.5 root gr. This is going to move like this way. The smooth surface is there. Block leaves the surface at this point C. It is leaving, and this is point B where it is entering into circular path. Angle theta is there. Now, if you want to solve fast, now let me tell you, if you want to solve fast, you must mug up the formulas. You must mug up the formulas, and quickly within few seconds you can solve. But let me tell you, I don't have to remember all this formulas as a teacher. And with practice, you can remember it. Suppose if I am teaching circular motion for entire week, then I may remember it. But if I am teaching optics, I may forget that. Right? But as a student, you have to mug up this. So do you know at what angle normal becomes zero? If you know the formula, you can do. If I don't remember the formula, then I will just thinking of energy conservation. This height will be what? This is r cos theta. So this is r 1 minus cos theta. I know normal has become 0, so this is mg and this is theta. So mg cos theta is only going to give centripetal. So mg cos theta has become centripetal. That means mv square by radius. M get cancelled. V square has become gr cos theta. We know that. Okay. And normal has become 0. So that's the condition. Now apply energy conservation. Energy conservation. So here speed will be v square equal to this square. Square of this means how much? Gr by half square 4. V square equal to u square plus 2gh. H is what? R1 minus cos theta. Now we'll substitute and solve. So v square becomes gr cos theta. And now it's over. Now one step solve this. Gr by 4 plus 2gr 1 minus cos theta. Now how fast you can solve that is depending on you. Gr cancelled. Right, I take LCM 4 and solve this. So this become 4 cos theta. That become 1. 4 into 2, 8. 8, open the bracket. 8 minus 8 cos theta. Open this, solve this. 8 plus 4, 12 cos theta. 12 cos theta become 9. Cos theta has become 3 by 4 over now. Theta is cos inverse 3 by 4. Clear? So I may remember it or I may not remember it, but with practice we can solve questions. Hardly it may take 2-3 minutes extra if it is very lengthy. With practice we can solve it. Okay, so that's the question. Let us move next question. Next question, question number 2. In the figure shown, PQR is a curved vertical surface with rough inner surface. Okay, so there is a surface like that, and this is an inner surface, is rough surface. Okay, with the floor is smooth. Which floor? The rough inner surface with the floor is useful. Curved vertical wall with rough inner surface with the floor is smooth. Okay, what is the question is that the radius of the curved wall is r and its length is quarter. Okay, all this information is given. The particle of mass m is projected on the floor at P like this, grazing the rough wall as shown. Initial velocity of the particle at point Q. So here you are throwing a particle projected like a tangentially V naught along this path it is projected and it is going and going to reach at the top. So what will be velocity here? This is again the vertical circular motion equation. And we are saying that there is a friction coefficient mu here. Coefficient of friction mu. Radius. What is capital R here? Not mentioned. But radius is small r, they have mentioned. Okay. So the particle is going to move in this path. It is moving, moving, moving. It will be coming up at this point exactly like this. So they are asking what will be the velocity here. That velocity we need to calculate. How will you do this? Again, what? Work energy theorem we can apply. So at any instant you see the particle is here and let us say it has some velocity v here and let us say it is this is radius, right? And we can apply work energy theorem again. The forces which will be acting in same way, mg will be there, normal will be there, and as it is moving forward upward, friction must be there, right? Let us apply that condition. So work done, net force mg plus work done by normal plus work done by friction is equal to change of kinetic energy. So half m v square minus v naught square. Okay, this is what it is. So work done by mg is mg into h. It is going up, so negative, so minus, right? Minus mg. Work done by normal is 0 because normal is acting always perpendicular. Plus work done by friction. Friction is integration. Minus will be coming. F dot dr will be coming. So half m v square minus v naught square. Right? So what do we want to calculate? We want to calculate that. But friction will be mu times normal. Friction will be mu times normal. Normal will be how? How will you calculate normal? Again, same approach. Normal is this way, mg cos theta. Suppose if I take this angle as theta. So normal will be mg cos theta plus mv square by radius. Correct, na? Like this you have to do. Similar way. Is it the same question or what that we were discussing? It is going from bottom to top, that was coming from top to bottom. Is it the same question or what? Hmm. It's okay. Hmm. That's what it is. But it is a similar approach. I think we need to solve that. Huh? Looks like that it is an advanced question or what? They have given advance or what? Hmm. Look like that. Correct, na? I think it is a similar way because here, but here the angle is increasing, so you have to take. I think it's the same way because options what they have given, the options what they have given are like that only. Let me tell you the options first before I solve this question. Option A is given as V equal to V naught e per power mu pi. Option B is given as V equal to V naught e per power minus mu pi by 2. Option C is V equal to V naught e per power mu pi by 2. Option D is equal to 0. Hey man, it looks like people power some factors like that. What we have got? We got people power c mu minus some factor, na? I think the solution of that may come by that integration approach or what? What do you think? Ah, won't be zero. So maybe you can remove some of the options. Huh? Some of the options you may remove. But they have not mentioned any other condition. But now you think what can be? How will you solve this question? Do we need to go by the same approach because it is going to be lengthy approach? No? What do you think? Really good question, no? Yeah. Hmm. What else? No, no. Conservation momentum in net force is zero. Then only you can. So what else can we do? Hmm. I think this should give some more conditions to be able to solve this. Otherwise, it is going to be big calculations, right? You may try to write kinematic equation. Already we have written this, right? And if you want tangential, so mg, suppose this will taken, so friction plus mg sine theta, friction plus mg sine theta, that will be mass into acceleration, correct? No? Mass into acceleration. And speed is decreasing, so acceleration can be written as v dv by dr, v dv by dr, but with a minus sign we have to write. So friction is mu times normal plus mg sine theta. That can also be written like this, but from here normal, can we substitute normal or what here? If you substitute normal here, try to substitute normal here and check, will it help you to solve that? Suppose normal I substitute, huh? 1 minute, let me substitute this first. And this plus mg sin theta is minus m v dv by dr. Is it possible to solve? Because theta is also changing here. So maybe I can bring theta terms one side. But again, the same idea is happening. It is not easy to solve. It may become a differential equations. Okay, so uh, we cannot do it either way. We may neglect or something or what. Gravity effect. If gravity effect is neglected, then only we can solve it. But I don't think gravity effect should be neglected. Okay. That person has means my student has sent me the solution, but the solution they have neglected gravity itself. That is not good. Hmm. What? What? No. Where? If you go here, normal may become 0 here. We have seen that. Normal becomes, but here if it is stopped, then only normal becomes 0. Here it is not stopped. In that case, you remember, we have released, so speed was 0, so normal was 0 at that point. But here it has speed, so normal will not be 0. Okay. Hmm. Hmm. No, first of all, logic if you apply, suppose you apply logic. So speed decreases, that you know, and speed is not 0. And e per power this factor mu pi by 2, this can be greater than 1, so all these speeds are increasing. By logic you can simply go with option B. By logic you can make anything. Okay, by logic you can go with option B. They have given this option B correct by logic, but logic will fail if the options are here, some minus terms also appear, then your logic will not work. Okay, but what I am concerned is that they have not taken G here. G they have taken as 0, and by taking G as 0 they have solved this. Suppose they take G 0, suppose they take G 0, then you get mu mv square by r is equal to mv dv by dr. So from here m get cancelled, v get cancelled, and here mu dr by r comes out, right? And here you get dv by v, correct? Then you try to integrate it. Okay, so suppose I integrate it. Velocity, initial velocity is v naught, final velocity is v, radius is anyway, what is this dr? Dr is dr, I think this r is radius, it's constant. Dr you have to write as what? I think mu by r you have to take. Dr is the integration of the path length, which is nothing but distance moved. This will become ln v, and v goes from v naught to v. Okay. So from here, you may try to calculate. What do you mean? And I told, I think minus was that. Yeah, this minus sign I missed to write. This minus is there now. This minus I forgot to put it. Okay. Minus is there. Let's bring minus here. So minus mu by r, and this dr integration is the path length, which is a quadrant circle, so that means pi by 2 into r, and this ln v by v naught it becomes, but from here r get cancelled, so ln v by v naught becomes minus mu pi by 2. So then v by v naught becomes e per power minus mu pi by 2. Then v becomes v naught e power minus mu pi by 2. But my question is that you got this by taking g0. Why? Why? Big Y is there. Why G should be taken as 0? Is it a horizontal circular motion or what? Are you playing with the question? Are you making this horizontal circular motion? If you keep a horizontal circular motion, then you can take G0, because then vertical will be not there. Okay. So might be in the question setter they should have put it as a horizontal circular motion. Then this issue would not have come. Okay. That is why the question setter should have told that it is a horizontal circular motion. Then this issue will not come. Let me read again the question. Are they saying horizontal circular motion or what? Rough inner surface with the floor, curved vertical wall with rough inner surface. That is a horizontal circle, man. Oh. See, I will tell you what it is. I will draw a diagram. So, see, this is like a wall. Okay, this is like a wall. This is like a wall. Okay, like a wall, and the object, and this is a horizontal plane, so body is going actually in horizontal circular motion, but this wall, it is in contact with this wall, inner surface of the wall, because it is in contact with inner surface, and here bottom the ground is not giving any friction, only friction is due to the contact surface. So this question is, Horizontal circular motion. This is the most confusing item. Horizontal circular motion question it is. Okay. So this question relates with horizontal circular motion. And from where the friction is coming? Friction is coming because of the contact with the surface. It's moving like this now. It's moving like this horizontally. So it is contacting the inner surface of the wall. Because wall is vertical, but it is not climbing over the wall. Are you understanding this? Yes. So that's why. But suppose the same person would have come for a vertical circular na, then gone case. Then gone case means not able to solve. Most of the people will not be able to solve. Okay. Most means what? 99% will not be able to solve. But now you know the method how to solve it because we solved the first question for half an hour more than that. Clear? Understood? The same approach you will apply and you can solve it. Okay, so if you want, you may leave because I will try to solve more questions. Okay, then let us go to the next question. Question number 3. A long horizontal rod has a bead which can slide along its length. Horizontal rod and initially placed at a distance of L from point A. Rod is set in angular motion about A with constant angular acceleration. If the coefficient of friction between rod and bead is mu, gravity is neglected. Then time after which bead. Good question it is. So this is like this, and this point is A. This is a rod. This rod is going to rotate about this point. Okay, and there is a bead here. There is a bead. This bead is hanging over it, and total length of this rod is L. Okay. Hmm. Initial placed at a distance of alpha. Okay, initial distance of bead is there. So bead is at a distance from here L. Initially time 0. Time 0. Rod is set into rotation with a constant angular acceleration. Alpha is a constant angular. Coefficient of friction is mu here. Mu is coefficient of friction. Gravity is neglected. G you take as 0. G is not there. Okay, then the time after which the bead starts sleeping. The time after which bead will start sleeping, that is the question. Time after, so this question is a main question, let me tell you. It is starting rotating, so at one particular angular velocity, friction will not be able to supply the centripetal force, that's all. So suppose it is going in a circular motion and this radius is nothing but L. So you know friction has to only give the centripetal m omega square radius, right? Radius is L. Friction, but you know that friction has to be less than equal to maximum friction, which is mu times normal. And normal is to be nothing but mg only. So mu into mg, right? So now you apply this condition, m omega square L. So mass get cancelled. So omega square or omega must be less than root under mu g by radius, which is L. Correct? Now we can calculate or let it keep in this term. Now when is omega? Omega has to be less than that. When omega becomes equal to this is maximum omega. When omega become equal to this maximum omega, it will start sliding. And it is a constant acceleration, so omega equal to omega naught or omega. You remember acceleration formula: omega 2 omega 1 plus alpha into t time. Okay, so omega final omega become maximum, so root under mu g by L. Initial was 0 plus alpha t, so we got the answer. Time when it will start sliding is root under mu g by L and alpha is outside. This is the answer. Time when sleeping starts. Okay. The coefficient of friction between gravity is neglected. Gravity is neglected. Oh, gravity is neglected. Let's check that. Gravity is neglected means then what will happen? Hmm? Friction is this, but friction has to be less than equal to mu times normal. Normal is mg. Gravity is neglected means then it will become what? What it will become? Huh? Check out this. Any mistake we have done? And it should be 0, na? That option is not given. Check this again. Hmm. hmm. Horizontal rod with a bead can slide along this initially placed distance. The rod is set constant in the acceleration. Coefficient of friction between the time of release starts sliding. So the friction is going to give m omega square L. So friction has to be less than equal to maximum friction. Maximum friction is mu times normal amount of omega square L. Omega must be less than equal to root g by L. Correct, na? This is correct. That's the maximum. Now omega equal to omega 1 plus alpha t. So time is equal to this. Any mistake is there in calculation? Check that. Any mistake is there? Check this calculation. Any mistake is there? I don't think it is. Direct questions are not. G is effect of gravity is neglected. See, if gravity itself is neglected, then how friction will be acting now? Friction itself will not be acting now. Correct, na? If friction itself is not acting, then who will give the centripetal force? Because we are taking friction. Friction has to only give the centripetal force, right? Is there any problem with this question? Let me check about this. Okay. Um, Friction has to act parallel now. How it is possible? Hmm. Normal, how will you take? I'm considering it's a horizontal circular motion. What normal can come? Okay, one thing is also important that because there may be also tangential acceleration. Tangential acceleration is r into alpha, radius is L alpha. So because of tangential acceleration, there will be a tangential force. Will this tangential force can give a normal? Might be possible it is because there is no gravity. So maybe here we need to add mu times normal. This effect we can neglect, but mu times that tangential force we have to add here. Tangential force you add. Tangential force means mass into tangential acceleration, which is L alpha. Maybe this. Let us try this. Then here you have to keep it as here you have to add this term. Mass terms will cancel. So mu, this term will go away. So mu L alpha terms will be coming. So here this term will go away. So mu alpha terms will be coming. L alpha. L will also go away. So root under L alpha. Yeah. Try that. So here we have to put it as L alpha. So try this. This term you change root of L alpha. So root of L alpha divided by alpha, then it will become root of L by alpha. Yes, this will be the answer for this. Definitely, it's a good question. So normal due to this mg forces are not that, but normal is acting because normal will be giving the force, tangential force. So that tangential force is the normal force. Good question it is. Next, definitely this is a good level of question. Let us go to the next. Question number 4. The block shown in the figure is compressed by a distance of this x naught. So there is a spring and there is a block M and this is going like this way. This block was compressed, okay, by x naught and released such that when it reaches a point A on circular track, contact force between the block and this is equal to. So when it reaches the top at that time, the normal contact force and mg is also acting downward. The normal contact force is equal to mg. Okay, they are saying it like that. So we have compressed it by some distance. Okay, and this is not in contact means this is a loose spring. Okay, spring is not connected with this block. Spring and block are not connected, but we compress. So if you compress, you will store potential energy half k x naught square. This will convert into kinetic energy half m v square, right? And with that kinetic energy, it will be going here, then it will have some speed here. So here first of all normal plus mg, that means 2 mg will be giving the centripetal mv square by radius. Radius is, let us say, r. So from here v square becomes 2gr, that we know. Now apply energy conservation here. So here you have given kinetic energy or potential energy same. So bottom half k x square is the x naught square is the only energy. Finally at the top we have kinetic energy half m v square. This v square is 2gr plus mg into 2r is also there because height is 2r diameter. Now I think we can solve from here. So that becomes how much? Mgr plus 2. So 3 mgr it becomes, right? So that is half k x naught square. So now from here we can try to solve x naught square. X naught will become root under 6 mgr by k. That should be the answer, right? Then let us move to the next question. Next question, question number 5. The overbridge of a river is in the form of a circular arc of radius of curvature r if m is the combined mass of motorcycle and rider. Yes. Yeah, please. The overbridge of a river is in the form of a circular arc. If m is the combined mass, is at the highest and the thrust on the bridge at the highest point. So there is a bridge here. So when this whole object is coming here, total weight is acting downward, right? Mg. Normal will be acting like this way. Net force toward the center is mg minus normal. That will be mv square by radius. Okay. Now the question is the thrust on the bridge at the highest point. Thrust means what? Thrust means I think the normal only. Thrust means normal. So normal will become mg minus mv square by radius. That is the thrust. This is the thrust. Okay, next questions. Some of these questions are quite easy questions. We have to selectively choose questions and solve. Question number 6. Question number 6 is the toy racing car moves with constant speed around the circle shown below. When it is at point A, its coordinate is. So there is a circle and this is x-axis, this is y-axis, this is point A. Coordinate is x is 0, y 3. So this coordinate is given 0, 3, right? And its velocity is given along x-axis. Velocity is 6 I cap they have given. Okay, meter per second. When it is at point B, its velocity and x. And they are asking when here. Definitely, velocity this way means it is going like this way. So here it will be like this direction. Velocity will be 6, but it will be along j dash. Acceleration they are asking. So radius they have given. This is the radius 3. So constant speed it is going only centripetal acceleration. So acceleration will be this direction, right? Centripetal acceleration. This is v square by radius. 6 square by 3. So 6 square 36 by 3 volt. Correct. So acceleration will be 12 I cap, and velocity will be 6 theta. That's the answer. Some of these questions are quite easy questions. I think the paper we have to be very wise to choose questions and solve. Next question, question number 7. Massless thread passes through a ring, smooth ring. Massless thread passes through a ring. Ring is in circular path with part of the thread is in tension. Which part of the thread is in tension? They are saying. So here there is a ring and it is like this way. Okay, and they are saying that these angles are alpha alpha, and it is going in a circular motion like this way. Okay, so massless thread is massless. Ring is in circular path with both part of the thread in tension. Which of the following? Okay, I think this is theta. This angle is theta, and this angle is alpha. Okay, which of the following values of theta and alpha are possible? Ring is in circular path with both part in tension. Both are in tensions. Both are in tension. So let us say here tension is T1, here tension is T2. So definitely we can resolve this because this is theta. This also will be theta. So tension T1 sine theta it will be. Similarly, this is also alpha. So that side also T2 sine T2 sine alpha. So T1 cos T1 sine theta plus T2 sine alpha, that must give m v square by radius or m omega square radius. Which of the following values of theta and alpha are possible? They are saying also vertical component must cancel. So T1 cos theta and T1 and T2 cos alpha must balance it, right? So T1 cos theta is equal to T2 cos alpha. They must balance. So we have this equation and we have this equation, correct? Now what is the question is, they are saying which of the following values are possible. Theta is greater than alpha theta. So what are the possibilities they are asking? So if you want, you can substitute T1 in terms of T2, right? T1 in terms of T2 can be substituted. Substitute T1 in terms of T2, so that will become T2 sine, that is sine theta, of course. T1 I am substituting T2, so cos alpha by cos theta, right, plus T2 sine alpha is equal to mv square by radius. Okay, so from here, what can be concluded? T2 I can take, cos theta is LCM. Sin A cos B plus cos A sin B can also be written as sin theta plus alpha, right? And this is mv square by radius. Okay, so we can get some ideas from here, then which of this can be assumed to be correct. Is theta greater than? How do we conclude that? How do we conclude anything about it? Which theta is larger, whether theta is larger than alpha or alpha is larger than theta, or theta and alpha are equal. Hmm. Is there any symmetric conditions? Master thread passes through the ring. Which of the following values of theta and alpha are possible? Is theta greater than alpha? Is it possible? Theta is greater than alpha. Yes. Is it possible or not? How can you decide? Because this is 90 degree, this is also 90 degree. Or is it symmetric conditions? Yes. How can we decide whether it is greater or not? Did we draw proper diagram? I think MG we have not drawn. No? This MG also must be there. Okay, I think they are not equal, so we have to consider the effect of mg also. If you take mg effect plus mg is also there. So from here, then we may try to substitute it, right? V1 cos theta. If now you substitute that, what do you get? Mg is anyway constant. The tensions are not. Is it the same string or what? If it is the same string, then tension must be same. Let me check that. Is it the same string or what? Is the string same or what? Same string it. So the tensions are equal only. Okay, okay. So tensions are equal. Then this is T cos theta is equal to T cos alpha plus mg. I think from here we can now decide because tensions are same and this side we have added, so alpha must be smaller than theta. Okay, we can conclude from here. Same string, it is not different string. Because string is same, so tensions will be same. So we don't need this equation. We don't need this equation. We can definitely solve that. Okay, so like these questions are very good questions. Technical questions are there, and we will be continuing discussing further in the next classes, right? So thank you all for your attention. We'll see you next class. Bye bye.